Hello students, let us find out the current distribution in the simple parallel combination of the circuit. Here we have two resistors R1 and R2 in which the current is flowing. We have to find out what is the current flowing in R1 and R2. Now from the figure we can first of all find out the total current in the circuit. So total current in the circuit is equal to total EMF divided by the equivalent resistance of the circuit. Now in the parallel combination, the equivalent resistance R equivalent is equal to R1 R2 upon R1 plus R2. So this is 3 multiplied by 6 divided by 9. So R equivalent comes out to be 2 ohms. So the total current in the circuit is equal to 12 volt divided by the equivalent resistance of the circuit, that is 2 ohms. The total current in the circuit comes out to be 6 amp. Now let us assume that this current is divided into two parts, I1 and I2, where I1 is current through R1 and I2 is current through R2. Also, you can write I2 is equal to I minus I1 from the Kirchhoff first law or a junction law. Now let us apply Kirchhoff second law to the loop A, B, C, D, A. Now when we apply the law in the direction of the current, the potential difference is minus, so minus I1 R1, and from C to D the current is coming from the opposite side, so potential difference is positive. Now instead of I2 we can write I minus I1, so R2 I minus I1 is equal to 0. We substitute these values, so minus 3 I1 plus 6, total current is 6 minus I1 is equal to 0. Opening this bracket, we find out that minus I1 plus 36 is equal to 0. So I1 comes out to be 4 ampere. Now if total current is 6 ampere, out of which the 4 ampere is flowing through R1, and I2 is equal to I minus I1. So I2 comes out to be 6 ampere. Now this is the method where we have applied the Ohm's law as well as the Kirchhoff second law. Now let us see another method where we can simply do the division of the current directly by remembering one formula. So this is a parallel combination of two resistors. So in parallel combination the potential difference is same. So V1 is equal to V2. Then V1 is equal to I1 R1 is equal to I2 R2. Here you can take the ratio of I1 upon I2 is equal to R2 upon R1. Or you can also write I2 upon I1 is equal to R1 upon R2. Now here if we apply the component in the numerator, I1 plus I2 divided by I2 is equal to R2 plus R1 upon R1. Or I2 plus I1 upon I1 is equal to R1 plus R2 upon R2. Now this I1 plus I2 is the total current. I is equal to I1 plus I2. So that is the Kirchhoff first law, that is the junction law. So instead of I1 plus I2 we can write I upon I2 is equal to R1 upon R2 divided by R1. Therefore I2 comes out to be I R1 upon R1 plus R2. Similarly, if you solve this, I1 comes out to be total current I R2 upon R1 plus R2. So these are the two formula which can be applied directly to this simple circuit where the current is divided into two portions. So you can learn this formula like the current flowing through resistor 2 is equal to total current resistance of the first resistor divided by total resistance. Similarly, current flowing through the first resistor is equal to total current resistance of the other resistor divided by the total resistance. So you can remember this formula like this, because the current will always flow through a path which have a least resistance. So here I2, here you have a R1, here I1, you have a term R2. Now directly let us apply this formula. So I2 is equal to total current which was 6, R1 was equal to 3 divided by total resistance, that is equal to 9. So I2 comes out to be 2 ampere. So this is the 2 ampere. And I1 is equal to total current, that is 6, R2 that is equal to 6 divided by 9. So I1 comes out to be 4 ampere, which is this value. So this is how you can directly apply the formula instead of doing all this calculation.